In this section, we'll discuss the role of secrets and credentials and the strategies to store and fetch them securely in a Node.js application. If you think about your Node.js application, it really is an ecosystem of interconnected elements such as database servers, mail servers, APIs, and services, all working cohesively to offer features of the product. All of these services and resources are restricted by access credentials that includes usernames, passwords, access tokens, and other keys that we collectively term as secrets or credentials. A major responsibility and task are to securely manage and store these secrets in the application's ecosystem so that they are not compromised. It is quite obvious to say that credential theft can be fatal for any business and can lead to serious privacy breaches. In late 2016, two hackers gained access to Uber's AWS account. This was gross negligence as these credentials were stored in Uber's GitHub account and should never have been there in the first place. As a result, they stole personal information of over 57 million users and 600,000 drivers. Uber paid $100,000 to the hackers to destroy the data that they had. And the story didn't end there. As a result of this incident, Uber lost its valuation by about $20 billion. All of this because of gross negligence in managing their application's secrets. So let's examine a few ways by which we can store secrets and their benefits and pitfalls. To begin with, you should never store your secrets in plain text or JSON files, such as the one you see here. These can be easily stolen from the code base since they are sitting ducks on the file system. Additionally, from time to time, as the codebase evolves and matures, there can always be a possibility that this file is left or forgotten and could very well be picked up by a persistent hacker. It is equally important to ensure that if you do store credentials on disk, such as during development, you should never ever push them onto a version control system such as GitHub. While your repo on GitHub may be private, you still might have third-party apps that are authorized to work with your repo, and that is not very comforting when you have secrets in your repo. Besides, you may not want everyone on your team to have access to secrets, and GitHub doesn't really offer granular access control. So as a rule of thumb, make sure you list your secrets file or files in a .gitignore file at the root of your codebase. This will ensure that Git doesn't commit and push these files to the repo. This is critically important and much more than just a best practice when storing secrets. If you do wish to version your secrets, then you can use a tool like Git Secret, which allows you to generate an encrypted version of your secrets file using GPG encryption keys. You can then offer granular access control to select members of your team who can then decrypt the secrets file when needed. If you're deploying your application on a platform as a service provider such as Heroku, Google App Engine, or Windows Azure, then you typically use environment variables to store your secrets in production. Heroku, for instance, allows you to easily set the environment variables using a dashboard, while you'd configure them in a YAML configuration file if deploying your Node.js app on Google's App Engine service. To access environment variables, you'd simply access the process.env namespace in a Node.js application. While environment variables are easy to manage and implement, the fact that they are available process-wide and any Node.js app can easily access them exposes a potential vulnerability. In 2017, an NPM package called crossenv was found to be stealing environment variables and posting it to a remote service. Consequently, it was later banned by NPM. This brings us to dedicated secrets management solutions. If your application is on the AWS infrastructure, there are two dedicated products that can help you securely manage secrets and credentials. The first of these is known as the Shared Systems Manager Parameter Store, or the SSM Parameter Store in short. Here I am on the dashboard of an EC2 server instance, and if I scroll down here, we'll find the Parameter Store option under the Systems Manager Shared Resources section. The Parameter Store allows you to store resources such as database URLs and API endpoint URLs as simple strings. For credentials and secrets, there is the Secure Strings option, which stores key value pairs as encrypted data on the AWS cloud. For encrypting the strings, master encryption keys created by Amazon's key management service are used. The KMS is a managed service that allows you to generate and manage encryption keys for use in your apps. Amazon uses hardware security modules to protect the keys and is integrated with services and products on AWS. Once the secrets are stored, we can create an Identity and Access Management or IAM policy that grants our EC2 instance with the ability to read and decrypt secrets from the SSM parameter store. Such a policy would look something like this. Since IAM policies are available as metadata on the EC2 instances, your credentials can be easily accessed using Node.js packages such as AWS Param Store, which internally uses the AWS SDK to fetch, access, and decrypt credentials asynchronously using the SSM API, and without the need to hardcode or store anything on disk or even the environment variables. And best of all, this service is available to AWS users at absolutely no extra cost. Amazon also offers the AWS Secrets Manager, a managed and paid solution for storing, rotating, and auditing secrets for enterprise applications. One of the key features of the Secrets Manager is the ability to manage credentials for the Relational Database Service or RDS, which allows you to host relational database such as MySQL or Oracle, among others. Not only can you store credentials, but the Secrets Manager will automatically change and rotate them at preset intervals. Both the SSM and Secrets Manager solve a critical issue. They deliver secrets to your app directly on demand and not from a static resource that may be exploited. Moreover, secrets are encrypted at rest and can be periodically rotated. And by using strict IAM policy, we are implementing the principle of least privilege, which severely limits the consumer of these secrets. Let's now summarize a few other solutions that may be employed to securely manage secrets for your Node.js application. If you're using Docker for containerizing your application, then you can use Docker's built-in service Docker Secrets, which is an excellent solution that is available when a Docker swarm is used with multiple nodes. Secrets are encrypted using a 256-bit key and managed at the Swarm Manager node, and they transit to worker nodes using secure TLS connections, where they are mounted into a virtual file system for your Node.js app to access and consume. You also have products like HashiCorp's Vault, an enterprise solution for storing secrets. Vault also uses strong encryption to store secrets at rest in a backend store and provides them securely and directly to a running application, purely on demand and based on access control lists, which implement least privilege. In the case of a possible breach, the vault can be sealed, which essentially locks up everything, preventing all kinds of access to decrypted credentials. KeyViz is another dedicated solution by Square that encrypts and stores data like other solutions that we've discussed. KeyViz also offers a virtual file system that clients can mount to access secrets as pseudo files on a virtual drive. This also means that access control can be implemented using standard Unix file permissions. So to summarize, a dedicated secrets management solution offers the best level of security for storing and consuming secrets in production. Secrets should ideally be encrypted while at rest and during transit, and applications must be made to comply by the principle of least privilege, so that only those absolutely need credentials get access to it.